So we have the sine of 55 is to 21 as the sine of angle C is to 4. It's the first one. Gotcha now. You just throw it by my stuff out. So in order to solve this, guys, multiply the other side by 4. In the calculator then, we type 4 sine 55 over 21, hit enter. That decimal equals the angle C. Then you inverse it. Don't try and type it all in at once. And I get 8.98. Okay. At this point, since that was the first angle that we had found in the side-side angle case, what do we have to check? The second triangle. In order to check the second triangle, what we do is we take this value of 180, take 180, subtract the 8.98, you get 171.02, correct? If I add that to the original 55, I'm well over 180 degrees, which means how many triangles would we have? Just one. So you don't have to worry about it. I think what you had done for us, I think you were pressing the sine of 21 under there as well. Okay, remember it's just this, does that make sense? I bet you that's what you did through most of them. If you want to take that and fix it and just show it to me tomorrow, that's fine. Answers are, when I post the worksheet online, I left the answer sheet there. They might be rounded to the nearest 10th, but you're going to be close-ish. All right. Yes, sir. Not necessarily. You just always double check it. All right. Make sure your name's on it, send that up. Well, it's due right now. It was due then today. Don't have one. Yes, ma'am. That would be the whole. That's just off the whole thing. Might not have circled it. I might have gotten lazy and forgot to circle. I never get lazy. I've never been lazy in a day in my life. Ever. I've never been sarcastic either. Ever. Go ahead. What happened to this new leaf you were turning over? Oh, it's starting today. It didn't start yesterday or the day before. Yes, ma'am. Nope. That one you had to condense in order to condense it correctly. A lot of you guys see that correctly. I think the answer to that one was like 6 and 2, or 6 and -2 maybe. And I think even in that case the negative was actually worse. All right, ladies and gentlemen. So here's what we got today. Whoa. We have law of cosines. Again, I know that you guys have seen this before. I know that you've walked through these problems before. I know because Seb said so. And I know that even my guys that I had in regular geometry last year, we actually did a couple of questions on this as well. So it wasn't anything that was horribly scary, bad, new, or anything in that case. And what I want to do today is kind of go through a couple of setups of law of cosines, which is formulaic. And then I also want to spend a little bit of time talking. I have a couple of very simple word problems we're going to look at today. Tomorrow we'll get into more of the I won't say complicated, but more of the word problems that we'll look at going further into this, where you're going to have to start drawing your pictures and understanding how things are set up and stuff like that. I do apologize that I did not make a copy of the word ones I'm going to do later on here today, but it's only like 2 of them. It's not that bad. Usually a lot of times if you read it with me, and as I write it out, you can kind of draw the picture and see where it's going. It's not going to be a big deal. Like I said, law of cosines, we use this. We use when law of sines doesn't work. So when you have the law of sines, you have to have an angle and a side opposite. Cosines, but you don't. Basically, cosines are going to work when we use the law of cosines for side angle side givens or side. Okay. Those are the two scenarios that you'll wind up using law of cosines. Now remember, we used that sine trick yesterday for the area with side angle side. There is another area formula that we have for law of cosine stuff that shows up, and I'll show it to you guys here in a little bit. It's for when you have just all three sides. It's awesome. Anyway. I don't remember. But we'll get there. So, do you remember what law of cosines look like? Awful? Kind of. When you have law of cosines, you have basically you wind up with three different versions. And what happens here is that they alternate letters through. What happens is you want to deal with angles and sides opposite still. So if I'm looking and working with A and little a, like angle A and small a, I'd say that the side segment A squared equals B squared plus C squared minus 2BC cosine of angle A. There's a lot there. I'll give it to you on the final. I don't know if it's the test yet. I haven't decided. Now, what happens here is that this formula just rotates through the lettering. It just rotates through the lettering. So if I'm starting with A, then I have B and C, then I go with B, and guess what it's going to be on this side? A's and C's. Bless you. And then I do it again. There's a lot there. And what's weird with one of those things with the law of cosines is, I don't know if you remember this, but you only have to use it once. As soon as you use law of cosine once, you wind up with an angle and a side opposite no matter what. And then you just jump to law of sines. What's that? It's not that awful. It's actually pretty easy to use. I think it's easier to use than law of sines because it's straight through, as opposed to trying to make sure you're cross multiplying and move stuff around from the, out of the denominators and all that kind of stuff. I like it as cosines. Cosines is basically, as we get into it, it's a two-step equation. It's really all it winds up being. Let me show you an example. It's really easy to show you this with numbers. So we have triangle ABC, and we have little a is 12, little c is 16, and angle B is 38. Question. What do you think the first thing I'm going to do is? Draw a triangle, exactly. So I have ABC. And it looks like that. Be all right with that? Yeah. This is what looks like side angle side. This is forcing me to find a side length opposite which angle? B. It's forcing me to find the side length B. So what I do is I write out the law of cosines in terms of B. So the side opposite is the other two sides. So B squared is going to be A squared plus C squared minus 2AC cosine of B. And a partridge in a pear tree. And now, dun dun dun, you fill in the blanks. Is there any equation that I'm supposed to be solving for here? Is there any variable I'm solving for on the right-hand side? Do I already have a variable isolated? Yeah. This is nice when you have to find a side length, guys. It is quite literally plug and chug. So all you have to do is just type it in exactly the way that it's written. You type it in exactly the way it's written. We have, what is that? 12 squared plus 16 squared minus 2 times 12 times 16 cosine, what was it? Thank you. That's why I hate using this calculator sometimes. What was the angle we had? 38? Thank you. Bless you. So all of that equals b squared. What button do I have to press now? Root answer. Very good. Oh, not white. Y equals. Second. You tell I was using the other calculator because it's on the top left. And there's little b. When you start getting these, then you want to just, as you start picking away at it, round to the nearest hundredth again. If I round that to the nearest hundredth, we get 9.87, I believe. Okay. So now I have 9.87 for b. And now you can do law of sines. Because now I have an angle and its side opposite. What I want you guys to get in the habit of doing here as you're going through law of cosines is always, even though you start with one angle in this case, you want to find the largest of the other two angles that are left. Or if you have all three sides, you always find the largest angle first. Of the two angles that are left, A and C, which of them is going to be the larger of the two? C. Okay, bueno. So I'm going to set up and use law of sines to find C next. So we have sine of 38 is to 9.87. Sine of C is to 16. And again, guys, I cannot stress the importance enough of writing down all the info that you're going to put into your calculator before you do it. Because you could write down 16 sine 38 over 9.87 and take the inverse of that, but you might have accidentally wrote 16 sine of 30, you might have typed in 16 sine of 37, all right? The more I see, the easier I can figure out what you screwed up. Whether it was a okay wrong answer versus you have no idea what you're doing. You know, like forgetting what a 3 or a 2 is. I'm going to see you in 2 years when you go to graduate, and I'm going to give you a high five. Is that 3 or a 2? And you're going to look at me and just either shun me. Was that a 6? Was that 6 shots or 5? Frankly, in all the confusion, I forgot myself. So you have to say to yourself, do you feel lucky? Well, do you, punk? Dirty Harry? It was the. Yes, I get it. I'm old. Leave me alone. That means you're trying to take the sine value of an angle that's greater than 1. Or an inverse sine, excuse me. So I have that equals the answer of sine. You know what you probably did? And then I get what? 86.41. How about this? I talked about this with first hour, and I know law of cosines can get cumbersome, but I just found a second angle in a triangle using law of sines. So what should I technically check right now? if there is the ambiguous case going on, because I do have that. But what I have decided that, because it just gets to be real tedious, for law of cosines only, if you have to start your problem to solve the triangle with law of cosines, you do not need to check for ambiguous. Is that fair? Yeah, with law of cosines. If your first scenario is a side angle side or a side side side, I'm not going to ask that you check for ambiguous case with the law of, if you have to start the problem with law of cosines, you don't have to use ambiguous. Correct. But with law of sines stuff, if you've got the side side angle and you have to start with law of sines, then you have to check for ambiguous. Okay? Because you can't start a law of sines problem by using law of cosines. It won't work. All right? With that ambiguous style. Does that make sense? Because technically I can get a second triangle out of this one. It gets real nasty. So then all you have left to do is subtract these two out from 180. What you get for angle A? 55.59. Thank you. And there you go. So law of cosines, you have to use it once, and then automatically you're able to use law of sines because it generates an angle and a side opposite, and it's not so bad from there. Not too terrible? All right, let's try another one. This is the side, side, side scenario. What's that? I'll show you. Okay. First thing you do, obviously, draw the picture. We have triangle ABC. You've got side A at 8, side B at 18, and side C at 13. Little a is 8, little b is 18, little c is 13. Now, the one thing that you want to do, just like we did a second ago, remember I said, hey, find the next largest angle with law of cosines after we found that one side length? Whenever you're working with law of cosines, you always want to find large angles first. So in this case, which of those is going to be the largest angles? Angle B. Angle B is going to be largest because 18 is the longest side length. Okay? So what we do is we set up our law of cosines again to work with B's. And you'll notice when you start looking at your law of cosines, the first letter and the last letter are always the same. The rest of it just mixed together. Okay? And I don't know if you noticed that right away. All right, so we'll write out law of cosines in terms of B. So it's B squared, A squared plus C squared minus 2AC cosine. And again, we're going to fill in all at once. Excuse me. Let's see again. 18 squared is 8 squared plus 13 squared minus 2. Excuse me. Sorry. Devin, are you alive? All right, carry on. Before you do too much with this problem, what I would always recommend that you do is this. Simplify 18 squared. So we have 18 squared and we get 324. I'm going to simplify 8 squared plus 13 squared. And then I'm going to do 2 times 8 times 13. And honestly, this right here is the exact same thing as this. It's the same problem. It's the exact same problem. It just happens to have the word cosine in it. What would you do first here? You would subtract 2. And then what would you do? Divide by the -4. Good. You divide by the negative. You get what? -2.5, I believe. Explain why. Okay. No, it's not. It's not. Today it's not. Where's x negative if you're talking about ordered pairs? What quadrant? Where's x negative? What quadrant? Quadrant 2. X is negative here. One, two. So it's negative in 2 and 3. So that just means as you start thinking about angle-wise, if I'm getting a cosine value that's negative, it means I have an obtuse angle. And that's why that's happening. Well, apparently you'll be okay. So now, if I do the same thing here, guys, remember, this is just calculator from here. I have 324. I subtract 233. I get 91. 91 equals -208 times the cosine of p. If I divide 91 by -208, I get negative decimal jump. That negative decimal jump equals the cosine of an angle. How do you figure out said angle? Cosine inverse. Yep. Inverse cosine of your answer, and you hit enter, and you get 115.94. Yes, sir. Well, what happens when you work with ambiguous case, it's you check it after you find the second angle. So you're using law signs at that point. That's why I'm saying we don't have to worry about it, because it just gets really messy. I've done it in years past, and it's just I'm going to say it's okay not to do that. So now I have angle B at 115.94, which gives us an angle and a side opposite. Which angle should I find next? We would find angle C. Remember, you always want to find the next largest angle. Always go with the next largest. And again, here you're going to use law signs because you have an angle and side opposite. Because it alleviates the possibility of an ambiguous. So this will be 13 sine 115.94 over 18 equals the sine of something. So second sine of that answer. I get 40.5. And I get left over. Okay? And honestly, that's as goofy as law of cosine gets. Having to find an angle first is usually what people will screw up. And don't worry, it's okay if the cosine of an angle winds up being negative, because that just means it's going to be an obtuse angle, because cosine is negative in the second quadrant. Perfectly fine, right? Remember, we haven't done a lot of that quite yet. Like I said, I just wanted to get through all the calculator stuff prior to worrying about ordered pairs and why certain things flip over and stuff. Yes, ma'am. Either one is fine. I think if I give you a triangle, you can just list them inside the triangle or circle everything. All right, do this one. Take a minute, do that one, and then I'll go find my word problem. What's that? What angle did you have to find first? C, good. 105.11. What happened? Did you not get that? I'm sorry. Use this one. Get used to this one. You need to use this one. Trust me. Did you get that? Oh, sorry, that's A. Sorry. Then 180 subtract out 4704. 2785. Not too bad, is it? Okay. Let's have a little bit of fun. Hey, Devin. I have the homework posted, I think, already. If not, I'll be there in a minute. All right. I'm not there yet. Sorry, I didn't have this written out. I apologize for having to read my handwriting. So, anyway, two scuba divers, Mr. Seb and Mr. G, happen to be underwater at this time, and they are 20 feet apart. Okay? They see a shark. The angle of depression from Seb to the shark is 47 degrees, and the angle of depression from Mr. G to the shark is 40 degrees. How far are they each from certain depth of the shark? What don't we have? It's a great white shark and it smells blood. So, like you said, we need diagrams. Okay? Yes. All right, well, we don't have pictures of scuba divers. Oh, well. So there are two people swimming underwater. One here and one there. Okay. Okay. Two scuba divers. They happen to be 20 feet apart. Angle of depression. Remember, angle of depression is line of sight looking where? Down. Angle of depression from Seb to said shark. It's really bad. So we have a shark. Shocking me though. Angle of depression to the shark was what, 47%? And angle of depression from G to the shark was 40. We need to figure out how far Mr. G is. So we'll call this little g, and we'll call this little s for little Seb. What do you have to do first? Well, find the other angle. How do we find the other angle? All we have to do is subtract in this case. So let's see here. We get 47 and 40 is how much? Subtract that from 180, you get 93. So this is getting us into using what to find the other two side lengths? Do I have to use law of sines or law of cosines? Law of sines. Sometimes you just have to use law of sines to get yourself to go. So we'll use this 93 and 20. Get the sine of 93 is to 20. Sine of 47 is to Mr. Seb. And then we have the sine of 93 is to 20, as the sine of 40 is to Mr. G. At this point, you probably, most of you guys probably don't need to write out what the next ratio is going to look like. Probably go right to your calculator. If you want to write it out, by all means. If you want to just say, okay, I know this is going to be 20 sine 47, hit enter, divide by the sine of 93, and that gives me a length of 14.65. Okay. I can do that right off of here, unless I want to rewrite it all out. So, Mr. G, I'm sorry, Mr. Seb, is 14.65 feet away from certain. Hope he can swim fast. And then Mr. G would be 20 sine 40 divided by sine of 93. Oops. Stupid calculator. 14 or 22. 20 sine 40. I hit the wrong button. I have Mr. G at 12.87 feet. Actually, Mr. Seb is with the opposite. Yeah, but anyway. Sorry, you know what I mean. So I hope that Seb can swim faster. Well, actually, I hope that Mr. G can swim faster than Seb because the shark has less distance to go. So if Seb can swim at 10 miles an hour and G can swim at 12 miles an hour, who's going to get eaten first? Right, that is really fast. So I know. I don't know. I'm just making up numbers. Shark is going to die. Ooh, what do you want? No. No. I got rid of you. Look, we're doing shark pictures. Law of cosines and law of sines. Word problems.
Hey, Jack. Time to go. I'm getting you out of math. Let's go.
excited. So one time your sister did something nice for you. Yeah. No, come back real quick.
Hey, Allie.
Hi, Allie. Well, that was awkwardly. Here's what I got for us tonight. Oh, by the way, I forgot. I almost forgot. There's this whole thing. How do you find the area of a triangle given side, side, side? In other words, just like Shimky's shaking his head, no, this is stupid. It's silly. Find the largest angle first using law of cosines and use the trick that we showed you guys yesterday. Seriously. And I'm not lying to you. No, do not. No. All you need to do is take this, because this is going to be the one where you have the three sides. Find the largest angle, and then just use your 1/2 side, and then the sine of the angle. You can't figure out what the sine of 30 degrees is? Huh? Can't hear you. No. I can't hear you. I thought it was, yes. No. Opposite of a hypotenuse. 1/2. I know that. Yeah, really, guys, this is called Heron's formula. It's something that's taught pretty regularly, but there's absolutely no reason to use it. It is long-winded. It is too easy to make a dumb mistake. It's so much faster just to use law of cosines to figure out a missing angle and use that with that's 1/2 side times the sine of the angle. It is much quicker to do that route than it is to try to remember all of that with all the parts you have to put to it. Don't you ever see that again? Don't ever use it. It's just silly. Like I said, it's silly. Okay. This evening, I'm going to ask that you do these problems. I'm going to ask that you do those 8. Okay? I want you guys to do those. Those 30 through 36, those first 3. Those first 3 happen to be the type of problems that you have to decide whether or not you have to use law of sines or law of cosines to solve. Remember, if you have to use law of sines first, what should you automatically check? Second triangle. Unfortunately, your ambiguous case. After that, you just go on your merry way. If you have to use law of cosines first, you have to worry about ambiguous. And then the last 3 are some very simple word problems to get us started. We'll do a bunch more word problem stuff tomorrow. I got some really good ones to kind of fun. And then we'll start doing next direction. All right.